Question 5. Prove by contradiction. So this method, we assume the opposite. So we assume that when x is real and positive, then x plus 81 over x is actually less than 18. So we've taken the greater than or equal to and we've turned it into its total opposite, which is to say it is less than. Okay, not less than or equal to, just strictly less than. Okay, so now we've got to prove that this isn't possible. Okay, so if the assumption isn't possible, then the original statement must have been true. We're allowed to multiply through by x without affecting the inequality sign because x is positive. Okay, so if I times through by x, we'll get an x squared, we'll get an 81, our inequality sign doesn't change, and we have an 18x. If we move the terms so they're on the same side, bring the 18x across, we'll get x squared minus 18x add 81 is less than 0. And then very handily, this will factorise, and it will factorise into the same bracket twice. A minus 9 in both brackets to make a minus 18. Minus times minus 9 is plus 81. Okay. X minus 9 all squared is less than 0, therefore. Okay, so we're not solving this like we would have solved an inequality in Unit 1. We're just observing that this is not possible because positive numbers cannot be less than 0, well, not positives, but any numbers cannot be less than 0 once they're squared. Okay, so it's not really positives, it's any values. Okay, any numbers cannot be less than 0 once they are squared. Therefore, this is impossible. So our assumption, remember our assumption we were saying was that it could have been less than 18. Our assumption is incorrect and hence shows x plus 81 over x must be greater than or equal to 18. Proved.